Chapter 8. Sampling Distribution. Many business situations require that a sample be taken from a population and an analysis performed on the sample data. The objective of random sampling is to select data that mirror the population. Then when the sampled data are analyzed, the results will be as if we had worked with all the population data. Whenever decisions are based on samples rather than a population, questions about the sample results exist. Chapter 8 introduces the important concepts associated with making decisions based on samples. Included is a discussion of sampling error, as well as the sampling distribution of the mean and the sampling distribution of a proportion. Sampling error, what it is and why it happens. Regardless of how careful we are in selecting a random sample, the sample may not perfectly represent the population. In such cases, the sample statistic will likely not equal the population parameter. If this difference arises because the random sample is not a perfect representation of the population, it is called sampling error. Sampling error refers to the difference between a measure computed from a sample, a statistic, and the corresponding measure computed from the population, a parameter. Some fundamental concepts associated with sampling errors include the following. The size of the sampling error depends on which sample is selected. The sampling error may be positive or negative. There is potentially a different statistic for each sample selected. Sampling distribution of the mean. In business applications, decision makers select a single random sample from a population. A sample measure is then computed from the sample and used to make decisions about the population. The selected sample is, of course, only one of many that could have been drawn from the population. If all possible random samples of a given sample size were selected and the sample mean was computed for each sample taken, the sample means would vary above and below the true population mean. If these values were graphed as a histogram, the graph would be a sampling distribution. Therefore, the sampling distribution is the distribution of all possible values of a statistic for a given sample size that has been randomly selected from a population. When the average of all possible values of the sample statistic equals the corresponding parameter, the statistic is said to be an unbiased estimator of the parameter. An unbiased estimator is consistent if the difference between the estimator and the parameter tends to become smaller as the sample size becomes larger. An important statistical concept called the central limit theorem tells us that for a sufficiently large sample size, the distribution of the sample means will be approximately normal, with a mean equal to the population mean and a standard deviation equal to the population standard deviation divided by the square root of the sample size. The larger the sample size, the better the approximation to the normal distribution. In this chapter, you need to know 1. Understand the concept of sampling error. 2. Determine the mean and standard deviation for the sampling distribution of the sample mean x. Outcome. 3. Understand the importance of the central limit theorem. Sampling distribution of a proportion. In many situations, the objective of sampling will be to estimate a population proportion. Sample proportions are subject to sampling error, just as sample means. Again, The concept of sampling distributions provides a way to assess the potential magnitude of the sampling error for proportions in a given situation. In those situations where you are interested in determining the proportion of all items that possess a particular attribute, the sample proportion will be the best estimate of the true population proportion. The distribution of the sample proportion is binomial. However, if the sample size is sufficiently large, then the central limit theorem tells us that normal distribution can be used as an approximation.